Hi everyone! Today we're going to be talking about compound statements and truth tables. Our objectives for today are that students will be able to determine truth values of negations, conjunctions, and disjunctions, and you will be able to organize truth values using truth tables. Let's get started. Alright, the first thing we want to do is define what is a statement when we're talking about compound statements in geometry. So a statement is a sentence that is either true or false. Alright, so it's the same just like in any other aspect of life. A statement is a sentence that's either true or false. This is called the truth value of the statement. Alright, so the truth value of the statement, is it true, is it false? This is a statement is represented using letters such as P or Q. Alright, you're going to see it represented using those two letters. And here's an example. All right, we've got statement P, and it says supplementary angles have a sum of 180 degrees. The truth value of this is true because supplementary angles do have a sum of 180 degrees. Negation is a term we use when talking about compound statements, and a negation of a statement has the opposite truth value. It is shown by the symbol, this little squiggly line, all right, and it's read as not P, all right. So if we have something that looks like this symbol stands for not, and if it looks like this where we have squiggly line P, this means not P. And the example of this not P is saying supplementary angles do not have a sum of 180 degrees. So we are negating the statement that supplementary angles do have a sum of 180 degrees. So we're throwing this word not in there, all right? So the truth value of this would be false. Oops, I need my pen back. Would be false because supplementary angles do have a sum of 180 degrees. Now, compound statements are two or more statements. All right, so when we take two or more statements and they're joined together by the words and or. All right, so we use and or. So think of compound sentences. We use the words and or to join two sentences together. With compound statements, we use the words and or to join two statements together. Now, when we're talking about a conjunction, all right, a conjunction are statements joined by the word and it's written as P and Q. All right, so the little up caret means the conjunction of P and Q. So this is true when both statements are true. All right, so a conjunction is only true when both statements are true. Now, statements joined by the word or are called disjunctions. And we write this as P or Q. So we do a little arrow pointed down. All right, and let me draw that a little better. That's not a very good arrow down. All right, so we want that to be a nice little down arrow. All right, that means P or Q. And disjunctions are true when at least one statement is true. All right, and we're going to do several examples to show the difference between both statements being true, at least one statement being true, and you will be able to tell the difference between a conjunction and disjunction. Both are compound statements. All right, so some examples. We're given three statements, and we want to write compound statements based on the notation given on our left, all right, given right next to the number 1. So after we write the compound statement, we need to determine the truth value. So first, starting with P, we've got statement P here, and it says that there are 7 days in a week. What I like to do is first identify the truth value of each individual statement. So P, there are 7 days in a week. This is a true statement, all right? Then we've got statement Q, March has 30 days. All right, this statement is false, all right, because March has 31 days. And then last but not least, we've got Halloween is on October 31st. This is a true statement, all right, because Halloween is on the 31st. Now, what we have written here is we have P and Q. So we want to write the P statement, join it with the word and then write our Q statement. So how we want to write this is we want to say there are 7 days in a week. All right, and then that up caret tells us we're writing the word and. Then we want to write our Q statement. So we have there are 7 days in a week and March has 30 days. All right, because we're saying P and Q. So then what we want to do is analyze our statements and determine the truth value of the conjunction. So because it's an up caret, that means it's an and, it's a conjunction. So both statements P and Q have to be true in order for the whole thing to be true, because it has to be this and this. Both must be true. So there are 7 days in a week. This is a true statement. And March has 30 days. Now this is a false statement, all right? So because one is true and one is false, they're both not true. So therefore, the truth value of our entire conjunction is false, because they both need to be true in order for it to be true. All right, now number 3. So number 3, we've got a conjunction again, and we're saying P and R, all right? So what we want to do is write this out. So we're going to start with our P statement. And P says there are 7 days in a week. So we're going to write that out. There are 7 days in a week. Then the up caret says we're writing the word and it's a conjunction. And then our R statement is Halloween is on October 31st. Now we want to determine the truth value of this conjunction, of this compound statement. So there are 7 days in a week is a true statement, and Halloween is on October 31st, also a true statement. So because both of our statements are true, both have a truth value of true, then our entire conjunction is in fact true. All right, we just did example number 1, and that had a true and a false, so therefore it was false. This has 2 true statements, so the truth value of this entire conjunction is true. All right, number 5. So number 5, we have P, and because this is a down arrow, this is saying or, and it's a disjunction. So we have P or R. And if you look back at your notes, we know with disjunctions, only one of them has to be true for the whole disjunction to be true. All right, so let's write it out. So start with your P statement. P says that there are 7 days in a week. And then the down arrow tells us that we're joining these 2 statements with the word or. So there are 7 days in a week, or, and our R statement is Halloween is on October 31st. All right, so now we see that we've got 2 true statements because P is true and R is true. So we've got 2 true statements, and even though it's an or problem, all right, only one of them has to be true for us to say that this is a true statement. But because both of them are true, it's definitely a true compound statement or a true disjunction. All right, number 7. So number 7, this states not P or not are. All right, remember the little squiggly lines mean it's a negation, so we're saying not P or not are. So what we want to do is write out the statements. We want to write out our P statement, but we want it to have the opposite truth value. So there are 7 days in a week. If we wanted to negate that or make it have the opposite truth value, we would say there are not 7 days in a week. So we're just throwing the word not in there. There are not 7 days in a week. And then we join them together with the word or. And then we've got our are statement, and we're negating our are statement. So we're saying, or Halloween, we want it to have the opposite truth value. So Halloween is not on October 31st. Okay. Now, we analyze this statement, and now that we've negated our P statement, there are not 7 days in a week, this is now a false statement because there are 7 days in a week. We've negated our are statement, and we say Halloween is not on October 31st. That is another false statement. So therefore, we've got 2 false statements. So the entire thing is false. All right? So if you have 2 false statements, the whole statement is false. All right, so on the next section of your notes, what I want you to do is I want you to write your own P, Q, and R statements, and they can be about anything, all right? Write something that interests you, write something that you can relate to, something that you're passionate about, all right? It doesn't have to be math related, just write 3 statements that either have a true or false truth value. Then what I want you to do is trade with a partner and fill in at least 3 of these. You can pick any 3 of these, and I want you to fill in 3 of these based on what your partner wrote for their truth statements, all right? Then you're going to trade back and check each other's work and see if you guys are on the right page. If you have any questions about this, call me over so I can help you out, all right? Otherwise, let's move on to the next thing, all right? So pause your video and do this. When you come back from having it paused, we will move on to truth tables. All right, truth tables are a convenient way of organizing truth values of statements. Basically, truth tables are a way that we can quickly organize the truth values of our negations, conjunctions, and disjunctions. So we're going to complete the following truth tables for negation, conjunction, and disjunction. So if you remember negation, what a negation does is it makes it have the opposite truth value. So when we're writing out the statement, we throw the word not in there, all right, because we're trying to make it have the opposite truth value. If we have a truth table that represents a negation, so we go from our P statement to not P. If our statement had a true value before, well, now it has a false value. And if it had a false value before, well, now it has a true value because we're making it have the opposite truth value. Now, these are the only 2 options you could have had for P. It was either true or false. So the only 2 options we have for not P are false and true. All right, so what I'm about to describe to you works for both conjunctions and disjunctions. So when we have 2 statements, we have P and Q. There's 4 different scenarios as what could occur, all right? We can have 2 true statements. We can have P be true and Q be false. We can have P be false and Q be true, or they can both be false. These are the only 4 scenarios, the only 4 outcomes that can occur when we have 2 different statements. So when we start our truth tables, we're always going to start with these 4 scenarios: true, 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 false, false, true, false, false. All right. Now, if you recall conjunctions, when we've got the prefix con, all right, if it's a conjunction, both must be true in order for it to be true, all right? So both must be true. This is an important thing to remember, all right, in order for us to make it a true conjunction. So if we're looking at P and Q, if P is true and Q is true, both are true, so P and Q is going to be true no matter what. Now, if P is true and Q is false, all right, one of them is false. That doesn't go along with our both must be true rule. So if one of them is false and it's a conjunction, then the whole statement is false. Now, the third scenario where P is false and Q is true, one of them is false. They're not both true, so this is false again. And last but not least, if they're both false, obviously the whole statement is going to be false. Now, a disjunction. When we're talking about disjunction, this is our OR problems, all right? And disjunction, we've got our down arrow, and only one of them has to be true for the whole thing to be true, all right? So only one, or at least one, must be true. Okay, for it to be true. So if we're looking, we've got our 4 scenarios. This is the only 4 scenarios that can occur. True, 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 false, false, true, and false, false. Now, both of them are true, so at least one of them is true, so we can say that this one is true. All right, P or Q, where both of them are true, is true. Now, if P is true and Q is false, well, at least one of them is true, so we can say that this is a true, it has a true truth value. All right, and then our third scenario, one of them's false, one of them's true. Well, at least one of them's true, so we can say this is true. And last but not least, if they're both false, it's definitely false. All right, so just going through some tips for constructing truth tables, all right? We're not going to do the super complicated ones in this class. We're just going to do some basic truth tables, but these are some handy tricks that you can remember to help you with truth tables. All right, so always include columns for each statement involved. If you've got P, Q, R, etc., one column per statement, okay? Also include columns for any negations that are required. So not P, not Q, not R, etc. And lastly, include columns for the compound statement. So we always want a statement at the end that describes what our compound statement is. All right, so number 1. Here we have P, and this is an OR, so P or not R. So what we want to do is start by writing out our columns for both statements. We have P and R involved, all right? Now, we don't worry about the not R just yet. We know we've got a P and an R statement, so we're going to write out what are the 4 scenarios that could occur for P and R. So we know that there's the 4 scenarios that always happen. True, 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 false, false, true, false, false. Okay? Now we want to think about our negations. We do have one negation here. We have a not R, okay? So we want to write that in its own column. Now the not R, what we're going to do is we're going to look at our R column and we are going to negate it. So if this is true, this has to be false, all right? If this is false, this has to be true. If this one's true, this has to be false. And last but not least, if the last one's false, this one is true. Okay? Now, our final statement, our final column is going to be our compound statement. So we're saying P or not R. All right? So remember, with our OR problems, at least one has to be true. Okay? So, if we're talking about our compound statement is talking about P or not R, the 2 columns we're going to look at are this column, our P column, and our not R column. So we kind of forget about our R column. All our R column did was help us get not R, okay? Then we want to look at those 2 columns and determine the truth value. So P and not R, we've got true and false. At least one is true, so we're going to say that this is true. Then our second scenario, we've got true and true. So they're both true, so it's definitely true. Only one of them has to be true. Then we've got false and false. So that is a definite false because they're both false. And then last but not least, we've got false and true. At least one of them is true, so we can say that this is true. And this final column is our final answer. We have true, true, false, true. All right. Now I have to see the whole table filled out, but we should have 3 trues and 1 false. All right, number 2. Number 2, we're saying not P and Q. So the 2 statements that we're dealing with here that we're starting out with are automatically just P and Q. Those are the 2 letters we see. So we're going to make a P and a Q column. Then we're going to list out all the scenarios that can occur, and it's the same 4 scenarios every single time. True, 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 false, false, true, and false, false. Okay. Now, we want to ask ourselves, are there any negations? So yes, we do have a negation. We have not P. So what we're going to do is write a column for not P. And then we're going to look at our P column to help us write our not P column. So negating P, or saying not P, is we're saying the opposite truth value. So the opposite of true is false. The opposite of this true is false. All right, and then opposite of this false is true. Opposite of this false is true. So then we've got true and true. Then lastly, we want to do a column for the compound statement. So our compound statement is not P and Q. So if you recall, when we have and compound statements or conjunctions, both need to be true in order for it to be true. Okay, so this tells us that the 2 columns we want to look at are not P and Q. So we're looking at these 2 columns. And it doesn't matter that they're switched around, all right? We just want to know, are both of them true? So we're looking here, true and false. Nope, one of them is false. They're not both true, so this whole statement is false. Then we've got false, false. So they're definitely both false, so the whole thing is false. The third one, we've got true and true. Look at that, they're both true, so we finally have a true truth value. And then last but not least, false and true. All right, they're not both true, so false it is. And you're done. Alright, so I want you to try to do number 3 on your own. Alright, it's very similar to numbers 1 and 2. Remember, start by writing a column for each statement involved. Then write a column for the negations required. Then last but not least, make your final column represent your compound statement. Alright, so go ahead and pause your video and try to do number 3 on your own. Alright, so you should have gotten a truth table that looks like this. So you started out with the 2 statements involved, Q and R, and then we've got our 4 scenarios, true, 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 false, false, true, false, false. Then we do a column for our negations, so we know we need a not Q. So we look at Q and do the opposite truth value. So the opposite of true is false, opposite of true is false, opposite of false is true, opposite of false is true. Then our last column is all about our compound statement. So our compound statement is not Q or R. So remember, anytime it's an or a disjunction, at least one of them has to be true for the whole statement to be true. So these are the 2 columns we're looking at. We're looking at R and not Q. One of them is true, so it's true. Both of them are false, so it's false. Both of them are true, so it's true. At least one of them is true, so it's true. Alright, so you should have true, false, true, true. Alright, the last one we're going to do today is number 4, and I wanted to do this one with you because we've got an extra column thrown in there. Alright, so I wanted to be sure you weren't too intimidated by this one. Alright, it's the same idea as 1, 2, and 3. So we're going to start by doing a column for each statement involved. So our 2 statements involved are P and R, because our statement says not P and not R. So we've got P and R, and we know it's going to be our 4 scenarios, true, 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 false, false, true, and false, false. Now, we do have two negations. We have not P and we have not R. So for not P, we're going to look at these truth values and do the opposite. So the opposite of true is false, opposite of true is false, then we've got true, true. Now for not R, we're going to look at these values and do the opposite. So the opposite of true is false, opposite of false is true, opposite of true is false, and then true. Now we've got our columns for each statement involved, our column for each negation involved. Now our final column is going to be for our compound statement. So our compound statement is not P and not R. So, and both need to be true for it to be true, all right? So we're looking at these two columns right here. We're looking at our not P and our not R. They both have to be true for it to be true. So first one is false, false. So that's an obvious one. It is false. Then we've got false, true. All right, well, they're not both true, so it's false. Last but not least, or third, not last, third is true, false. They're not both true, so it is false. Now, last but not least, we've got true and true. They're both true, so we can finally say that one of these is true. And we're done. All right, so I hope you learned a thing or two about compound statements and truth tables today. Look to the board to see what to do next, and remember to call me over if you have any questions, and I hope that you have a great day.